Who of you has used GnuPG to sign emails? Hands up. Who thinks that the user interface is awesome and useful to end users? Yeah. Who of you has used GnuPG to sign or encrypt something else than emails? Oh, you got an audience. We will change the number of hands with this talk. So, please welcome with a very warm round of applause Hans Freitag, and comparing GnuPG with Signal is like comparing apples with smart light bulbs. Welcome.
Yeah, hello, and yeah, let's start with my talk. Things you can do with GnuPG beyond writing emails. And I start with some news, which is ingenious in some way because it dropped into my filter bubble, and there were some headlines like expert believe that you shouldn't encrypt your email at all. It's time to drop PGP. I'm giving up on PGP. I'm using PGP and GnuPG for the same things during this call, during this talk. Because it's the open PGP standard, and GnuPG is an implementation of that. So yeah, and one of the headlines also said, "Oh yeah, I'm giving up on PGP. It's not worth it. Use messengers like Signal instead." Yeah, the thing is, GnuPG isn't only about messaging. Especially Signal collects phone numbers, or at least transmits your phone number to a secondary provider. So this is also bad. And biggest problem is that email is fundamentally broken, and but no encryption. Using no encryption there is even a worse option. So. Yeah, what is GnuPG and PGP? As I said before, it's PGP is a standard that was created at some point, and GnuPG is an implementation. And now I have some beginner slides for the 1 or 2 persons who don't know about asymmetric encryption at all. And so, as those are the basics for this, for some of the ideas behind, I will make a very quick rundown. So, asymmetric encryption usually involves 2 keys. You have some function here, which is called generate keys, and that function drops out 2 tokens. Or files, a public and a private key. And the idea with that is that you can use someone's public key, encrypt a message with it, and the receiver can then use the private key, which needs to stay safe, to decrypt the message. And only the owner of the private key can decrypt the message once it is encrypted with the public key. The funny thing is, this is going the other way around too. So you can have the idea that you encrypt something with your private key, and then it can only be decrypted with your public key. And if you do that, you have invented digital signatures. And yeah, that's all about it, basically. And all the rest is signing tokens. Of course, you have to have to have an idea if the public key you are using really belongs to the user that you want to send your message to. Otherwise, it doesn't make sense. And in the other way around, if you compare a signature, you have to have some idea if the public key that you are using to verify is actually a valid public key that isn't compromised, that is that belongs to the user, that is intent. So basically, PGP was developed in 1991 from a guy called Phil Zimmerman. It was developed in the USA, and the USA has some export restrictions on strong cryptography. So it can't be exported under a free license from the USA. PGP itself also had a lot of smaller problems, like it didn't deliver proper return codes. So if you wanted to have some automation in it, you had to check the output, which meant you couldn't change the output of the software, or every code around would break. So that was a bit of an issue. So fortunately, a guy called Werner Koch in 1997 started a project in good Germany in Europe, which doesn't have export restrictions, under a free license, and he basically rewrote PGP, and that's the implementation of PGP that we are currently using. During this process, a standard was developed, which is called the OpenPGP standard, and yeah, it's still a bit difficult to handle, but it has some defaults that I'm not quite happy with, and still no complete graphical user interface. So that's some issues, but it made a lot of things right, and yeah, it's used by many open source projects to ensure software validity. We come to that later. So basically, GnuPG itself is a framework for personal cryptography. There are some other standards like X509 and OpenSSL. Also, GnuPG implements those standards. So the thing is, OpenPGP itself isn't X509. Those are certificate standards. So the idea is you have a public key and you sign the public key, and once a signature is under the public key, it can be validated. That's the whole idea behind certificates. You somehow magically sign it. You add it's valid from 2 dates to the key. You add some user IDs to the key, and then you can verify if the public key you are using is really the public key you want to use. And there are different formats out there. So let's have a look at the OpenPGP format. OpenPGP usually uses more than one key. It uses a thing called main key, PGP Hauptkey in this slide. Sorry for that I didn't translate every word. So basically, the main key is signed by itself. You can do that. You have a token, which is a file. You can sign it, And then the main key signs a few more keys that you are used for your daily work. For example, you can assign a key that you are used explicitly for encryption. You can sign a key that you are using to sign other documents. You can sign a key that you are using for authentication. And the idea is that you can, with that, you can rotate out all your subkeys, so you can change your subkeys that you are currently using, while the main key stays safe and, in the best cases, even offline of the computer that you are using as your daily driver. So this is one of the things the main key signs. The other thing is it also can sign a thing called a revoke certificate, which is basically a file that says, oh, this main key isn't valid anymore, and if that file is going public, then hopefully everyone who owns that file knows, oh, it's not good to use that main key anymore. Yeah, and also it signs keys of your friends, which was one of the basic ideas of GnuPG, the so-called web of trust. So you have a bunch of people, basically, with web of trust, and those people are signing their keys. In a modern social network, but I would say those people are telling each other, oh, we are friends. And then you can verify if the person who owns the key really is the person that it claims to be. And also there are some user IDs that are signed from the main key, and the user IDs are basically email addresses most of the time. So you can look up the key. It's basically some sort of label. That user ID is that key, and that's how it looks on a Linux terminal. We have basically the main key on top. It's the first line. It's a fingerprint of the main key, and then you have some user IDs and signing, encryption, and authentication keys. So how to get a public key, or how to get a public key from the person you want to send data to, or you want to encrypt to. First of all, there might not even be one, which is the worst situation. But unfortunately still happens. But you can import one with a file, via file on your system. There is a download from WebKey directory, which is a thing that is connected to the email address in the key. So every email address forms a unique URL where you can download a key from. And you can also use one of the key servers, which just store public keys. Yeah, the web of. So, how do you ensure trust with that system? There are certain different types with GnuPG. The thing is, the web of trust with encryption didn't work very well. It was invented in the 90s. We were all enthusiastic about it, but right now this is also a bit of a problem. It just didn't work out that well. Certificate authority is another idea where you have a few central instances around that say, oh, that key is valid. This schematic is used for SSL encryption in your web browser, and it's also used. It's also used in can also used be with GnuPG. And finally, there's trust on first use. Trust on first use is you get a key. Once you have it, you probably verify it one time, and if the key changes or if someone provides you a different key, then you have to check more closely. The trust on first use is also the thing that SSH uses by default. So, yeah, those are the basic things. The web of trust itself didn't catch on, but I must admit I've heard a talk on the Privacy Week where someone mentioned regarding ActivityPub and Fediverse protocols. ActivityPub is social networking in open source on many small systems, and there was a mention that there are some thoughts to revive the web of trust with Fediverse websites. Let's see where this comes in handy. So we have with the key servers. A key server is basically a system where you can upload a key, where you can upload a public key, and then it's basically published. Problem with most of the key servers around is that anyone can upload a key that stays on the server, except if someone provides a revoke certificate. But that means anyone can spam a key with a signature. So anyone can, I create 1 million of keys, and then I pick out one key and I put 1 million signatures on it. And then the key gets published, and you have a published key with 1 million signatures. So this is a big problem at the moment. So the key servers aren't really reliable. So there are new ideas like Keys OpenPGPnet, which just provides a verification of the email addresses in the key. So with Keys OpenPGP, you upload your key, then you get a verification email. You click on the verification email and say, oh yes, the email address really exists. And then the key is validated. Problem there, not all keys are on the same key server anymore. With Keys OpenPGP, you can a key server can't exchange keys, so it's more difficult to actually fetch a key. Even if it exists, you have to know on which key server it is. Yeah, a certificate authority does mean searching for CA. And certificate authorities are also complicated. So, yeah, basically we have this with S/MIME standards in email. I have never seen one person who uses S/MIME in email because it's just even more difficult to say, oh, I want email encryption. I have to sign up with a complicated challenge response procedure just to encrypt my my messages or my files. And yeah, finally, trust on first use works with existing key servers. So how to keep the private key private? Of course, we can commit that we can't trust our user accounts and all applications in it, not in 2019, which is, it was a problem in the 90s also. The thing is, we run lots of applications, and if the key is just somewhere in your user's data, it can be downloaded by applications. And here comes in handy that the GnuPG is able to split the main key from the subkeys. So the basic idea to do that, why you do that, is that you can keep the main key on a separate system, and you can keep it offline. Then you can also encrypt your private keys with a symmetric passphrase. Then with that, once you are not using the GnuPG service, it's an idea, as long as you don't use it, it stays encrypted on your hard disk. Even if someone downloads the key, you are good. Problem with symmetric passphrases and encryption, you need at least, I would say, 40 characters randomly chosen to have enough safety for such an encryption key. And that's a bit hard to type in. So we have some solution for that. GnuPG agent service is basically an agent service that handles encryption. And the idea is you type in the password, the passphrase, and then the key stays in memory, which isn't as good as don't have it on the system at all, but it's much harder to get information out of the memory than from the hard disk. So it's basically an idea. So that agent service handles all the encryption tasks. It asks the user for passwords and secrets, and it also can simulate other common agents, like the SSH agent. So every tool that is around has its own agent. So the GPG agent isn't a unique invention. There are others who do similar things. And then you can do one thing. You can run the GPG agent on a dedicated system and just forward the connection to the GPG agent. And that system is locked down, and it only does encryption. And that thing is called a smart card. You probably have something like that in your mobile phone. There it is called a SIM card. It is basically a system. You have a password authentication there, and once you type in the password 3 times wrong, then the whole thing goes on lockdown, which means short passwords. So this is the whole service layout of the GnuPG infrastructure. I have some applications who are using GnuPG. You have the tool itself, that is the user front end. You have a tool, you have a service on the system running called Dear Manager that is able to fetch keys from a key server. You have an agent service that is able to provide an interface for encryption. And you also have a thing called SC daemon, smart card daemon, and PC smart card daemon. It has a root part. And the idea is that the GPG agent can forward all the encryption work to SC daemon. SC daemon can forward it to the system daemon, and that one can forward the connection to a smart card on a USB device, and there's your private key. For the people who want to look at the slides, I have written all of that down. And this is also where free open source systems like Linux and BSD come in handy, because they are delivering everything that was shown on the slides. So you now can use that out of the box. For example, to encrypt files. Encrypting files is the most basic task that GnuPG can do. Once you have all this set up, you have your keys generated, you have your keys private, you can just say, oh, I want to encrypt a file, and you are done. You can encrypt the file and send it over. You can also use it to encrypt whole directories with in combination with tar, and send the tar directories over. This is also a thing I'm missing in business a lot, because the infrastructure isn't there. You can't easily encrypt files. It's always a mess. Typically, if you are in a business company, it's some sort of zip file which is encrypted symmetrically, and then you have to think about how to share the credentials and so on. Why not using GPG? So now we come to the applications. As GnuPG is available in operating systems like Linux and is widely available, everyone can use it. It's almost natural that open source systems start using it. For example, in this case, the Fedora homepage is providing all the download images with the GnuPG signature. So you can download the image, and then you can verify if the image you have downloaded actually is from Fedora. So nobody can inject software there. There is a small problem, because most of the GnuPG keys are located on the same web page that you are used to download the image. But yeah, we probably someone is coming up with a better solution at some point. Then we have a download page of CubesOS here, for example, which does the same GnuPG signature, and then you can download the operating system. But it doesn't stop there, which is why I said earlier before the talk that I see not enough hands for people who have not used GnuPG before, because the key management of the operating system is GnuPG signed. So every package you are usually installing has a GnuPG signature on it. There are some honorable exceptions, like the OpenBSD people who made their own signing tool. But most of the operating systems are just using GnuPG. There's a key management tool within apt, which is called apt-keys, and it does some magic work and helps you organizing the keys that are valid on your system to install software. The next thing is with RPM. There's a similar thing called RPM keys, and also an RPM package can contain a GnuPG signature. Then, of course, you can use your SSH key with GnuPG. It sounds a bit strange at first, but it really makes sense. Once you have GnuPG infrastructure, you can basically do on every system GPG2 export SSH key your email, you get a public key, and you can put it into the authorized keys of the server. You don't have to copy around SSH keys anymore. The GPG agent itself has a few more features than the SSH agent product that SSH uses to handle encryption. Same principle, different two software blocks doing the same thing, providing the same interface. So when I didn't use smart cards back in the days, when I had my key encrypted on my system, I had some timeouts that released, that wiped out the key from the memory after a while, and you can configure much more in the GPG agent than in the SSH agent. So it really provides a benefit. And finally, if you are using GnuPG, it also provides you with the possibility to use a smart card. And that one drops out, that one gets rid of the need that you have to ensure that the client system really is safe. You should have your client system safe at all in any way. But if you think to enroll GnuPG to a bunch of people, for example, like in my company, we are 5 people using GnuPG, and you can guess that one of them will surely make some mistake to make the key public. So it is an idea just to use smart cards to make the system safer, to have a defined way to access the keys, and to have a defined way to have the keys secure without having to think about the rest of the software, which probably causes things. So with signatures, the author of a version-controlled commit can also be verified. Basically, all the decentralized version controls do GnuPG signs. We have also others like JIT, like Mercurial, Fossil. There's Monotone, who implements their own infrastructure. And JIT can be configured to accept pushes only with valid signature. This is how it looks. With JIT, you configure a few things that it actually uses your key. And you can also configure GitLab and all the other JIT systems to use your key, to verify your key. GitLab itself does a similar thing like the newer OpenPGP key server. It verifies your email address, and once that is verified, the key is probably verified too. And this is the basically the way to ensure that no one tampered with the JIT repository. So the next tool I want to show you is Password Store Manager. Password Store Manager is a password manager. It uses GnuPG, so no extra encryption tokens to remember, and it's basically it starts out as a shell script. The passwords are stored in a directory. Every password is in a GPG file, and that GPG file just contains the password. It can copy and paste to the clipboard, and it also integrates with JIT, so it can push and pull from a JIT repository. We have password store front ends, like one that I have written, one in Qt, and password store also works for smaller groups because it can encrypt to multiple recipients. And it automatically tracks and syncs with JIT. JIT itself also has some extra remote plugins. It can use remote gcrypt to safely store files on an SFTP server with zero knowledge. So the SFTP server only sees a few files. It can guess it's some JIT, but it doesn't know which JIT. It doesn't know what data is inside. Then we have a thing called Yaint another .file manager. This is a software designed to version control config files in your home directory, basically a wrapper around JIT. And it also can store credentials in a GnuPG encrypted file. So if you have multiple devices, you can just use JADM to get your config back. Next thing is LibreOffice. For those who don't know or don't use it regularly, it can encrypt files with GnuPG out of the box. So if you have some confidential document, you have all the infrastructure in place, you can click on encrypt and send it out with a nice front end. You can also sign documents with GnuPG from LibreOffice. Yeah, just works. Also, there's an infrastructure for Android, which is called Open Keychain. There's also a password store front end on Android, and this is the only email client you will probably see. No, it's not an email client, it's Open Keychain. But there is K9 Mail on Android that I use. So, next thing. Securely back up your server. The backup is a part. I had some friend of mine who gave me my root password, because I accidentally lost a backup. It's a few years back, but when you have these calls, you recognize, oh yeah, backup is a very critical thing. You want to keep your backup files safe because those contain all the credentials. So GnuPG helps with a software called Duplicity, and Duplicity creates an offline backup, incremental, encrypted with GnuPG on a remote system, on a remote SFTP server. And all you have to do is call Duplicity, tell it to which key it should encrypt to, which server, and which files. Big advantage, the server doesn't have to have the private key to create the backup. It only has to have the public key. The private key is not needed to encrypt, and that means the server can't decrypt the backup. To recover this, you basically forward your GnuPG agent to the server, and then you can recover. So it is possible, but you in the normal backup process, it's not needed to have the public key. So the next software I want to show you is called OTRS. It's a ticket system, and that one is able to receive GnuPG encrypted and signed tickets via email. And it's also able to send encrypted email. So with OTRS, we can receive encrypted emails from our customers and have the communication as a group with customers. Finally, we have some interface library. I think GPGME is widely used, so as far as I'm aware, Enigmail, which is the front end of Thunderbird, is using it, and all the others. So every application that is actually using GnuPG and integrating with GnuPG is using GPGME nowadays. Few exceptions, of course. You can also exchange some of the services. Like, for example, there's a thing called PKCS 11, which exchanges the smart card daemon, the SC daemon you have seen in the earlier slide, to access different smart cards. Basically, the smart card that is used with GnuPG as default is called an OpenPGP smart card. And then we have, there is also a smart card with a different operating system that is mainly used for OpenSSL and X509 certificates. And that is used with PKCS 11. And also there's some software I haven't reviewed yet. For example, Sqt, which is a plugin for Firefox to do certificate authentication with your GnuPG infrastructure. Then there is Creds with it, which has a similar idea than Password Store, but it's more of the DevOps kind of style because it creates environment variables. We have GPGSM for SMIME and X509 certificates, which is which uses the same keys but different certificate and key layout. And then there is a development called Pretty Easy Privacy, which makes auto configuration for PGP. So you can just set up an application, it will generate your private key for you, store it on the system, and so on. So, sorry that I rushed through the last slides so quickly, but now we have 1 or 2 minutes for discussions left.
Thank you very much. Yep. So, any questions? If you have one, please raise your hand so I can come to you with the mic so we have the questions on the recording. Questions? Who will use? Yeah, awesome. Start here.
Hi, would you say that recent events make OpenPGP unsuitable for a production environment?
I wouldn't say that. As far as I'm aware, there's it uses RSA, and if the key is long enough, RSA is okay. So I'm using it in production environment. The recent events is on key distribution, and so this is a bit messy at the moment. I admit that, but the encryption is safe. As long as you have a keyring and you have trusted keys in that keyring, it's perfectly safe, as far as I can say.
Hi, so what about the e-fail vulnerability thing? Is this still an issue, or how do you...
The what?
This e-fail vulnerability that was disclosed in 2018, where you are able to, with embedded HTML objects, to extract the plaintext content of an email and send it to someone else.
That was basically a problem with email clients, and not with PGP, which is always, it's all the news. It's all about email clients. There's problem with the software around, but not with the OpenPGP standard itself. It's so the e-fail was the idea that you have a mail and you have parts in it that are encrypted. Those parts are shown to you as, oh yeah, signature valid. And then you have some parts that are not encrypted, and those you can exchange those parts. And then you can have a message that is shown to you as encrypted because the email client is broken. And it also shows you the completely unencrypted part as valid private message.
Do you know if the email clients, the main email clients, have found a solution or have implemented a solution or workaround or some sort of checks for that?
I have to look at the client. As far as I'm aware, Thunderbird is okay, but I'm not sure if there's not any other bugs in Thunderbird. So always be careful if, as soon as you do messaging, cryptography is a hard thing to do. And as far as I'm aware, I have not seen a solution yet that is perfectly good with cryptography. It's always a bit messy.
And the problem started with HTML emails, so get rid of that.
Yeah.
No, any further questions? Otherwise, no. You're around. You're still around.
I'm around.
So if you have any further questions, he's still around. Grab a coffee. Thank you very much, Sam.